Hello my scholars, this is my school challenge where we are tackling the 2018 JAMB past question for mathematics. In this clip, we'll be solving questions number 51 to number 64. This is an exciting journey, so join me as we tackle question number 51. Out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? Okay, this is a question on combination. So this is very easy to tackle. So at first, the question reads, out of 7 consonants, okay, and 4 vowels. So we have 7 consonants and 4 vowels. How many words of 3 consonants, okay, and 2 vowels can be formed? You can see very easy, right? So, and means times. Okay, so let's solve this. That will be 7 factorial over 7 minus 3 factorial, then 3 factorial. Okay, times 4 factorial over 4 minus 2 factorial, 2 factorial. Okay, so that is 7 factorial over 7 minus 3, that is 4 factorial, times 3 factorial, okay, times 4 factorial over 4 minus 2, that is 2 factorial, 2 factorial. Okay, so if we expand this, we are going to have 7 times 5, 7 times 6 rather, times 5 times 4 factorial. I'm stopping here because 4 factorial will still strike out 4 factorial, times 3 factorial is 3 times 2 times 1, okay? We have the big times here. Let's make it more distinct. Okay, very well. So we have 4 factorial, which is 4 times 3 times 2 factorial over 2 factorial. 2 factorial is 2 times 1, okay? So when we look closely, we have 4 factorial strikes out 4 factorial. So we have 3 times 2, that's 6. 6 times 1, that is 6. So 6 strikes out 6. So we have left here 7 times 5, that is 35. Times, okay, let's move to this side. 2 factorial strikes out 2 factorial. 2 times 1, that is 2, okay? So 2 divided by 4, that gives you 2. So we have 2 times 3, that is 6, okay? So what is 35 times 6? Let's use our long multiplication method. 6 times 5, that is 30, 0 you carry 3, okay? 6 times 3, that is 18, plus 3, that is 21. So we have 210 ways on how they can be formed. That makes option A correct. Question 52. From a point P, Q is 5 kilometers due west and R is 12 kilometers due south of Q. Find the distance between P and R. So this is a question on bearing, so we have to just first represent the question in a diagrammatic form, okay? So from a point P, this is point P, we are told that Q is 5 kilometers due west. This way, okay? Q, P, 5 kilometers. Okay, so the question states further that, and R is 12 kilometers due south of Q. R is 12 kilometers due south, okay, of Q. So this is the south of Q, 12 kilometers. Okay, so the question requires that we find the distance between P and R. Okay, so we can just use the simple formula of Pythagoras theorem, which is hypotenuse squared equals adjacent square plus opposite square. Okay, the hypotenuse is the longest side, which is what we are looking for here. Okay, so that just brings it to show that. So we'd have 5 squared plus your opposite, which is 12 square, and that gives you, remember this is hypotenuse square, okay? 5 square is 25 plus 12 square, that is 144. If we add up, we are going to have hypotenuse square equals 169. So to remove the square and find the hypotenuse side, so we have hypotenuse equals square root of 169, and that makes it 13 or 13 kilometers. So the distance between P and R is 13 kilometers. So let's go through our options together. Option C is very correct. Here we have question number 53. If y equals 23 base 5 plus 101 base 3, find y leaving your answer in base 2. So what we just have to do is to bring both 23 in base 5 and 101 base 3 to base 10. Let's just bring them together. So if y equals 23 base 5 plus 101 base 3. So let's just bring both of them to base 10. So how do we do that? We just use the simple expansion form. Okay, so that is 2 times 5 raised to power 1 plus 3 times 5 raised to power 0. Okay, so if we pull this further, 5 raised to power 1, that is 5 times 2, that makes 10. Okay, plus 5 raised to power 0, that is 1. 1 times 3, that is 3. So this gives you 13 in base 10. Okay, so let me not just confuse us. Okay, we have plus 101 base 3. This is 0, 1, and 2. Okay, so we'd have 1 times 3 raised to power 2 plus 0 times 3 raised to power 1, okay, plus 1 times 3 raised to power 0, that equals 3 raised to power 2, that is 9. 9 times 1, that gives you 9, okay, plus 3 raised to power 1, that is 3, times 0, that gives you 0, plus 3 raised to power 0, that is 1, times 1, that is 1, okay? So we still have 13 plus 9 plus 0, that is 9, plus 1, that is 10. Okay, so that implies that 23 base 5 is equals to 13 in base 10. 101 base 3 is equals to 10 in base 10. So if we add up, according to the equation we have here, 13 plus 10, that is 23 in base 10. But we are required to bring our answer to base 2. So what you just have to do is to do this. We are coming to base 2. Okay, 2 in 23, that is 11, remainder 1. Okay, 2 in 11, that is 5, remainder 1. 2 in 5, that is 2, remainder 1. Okay, 2 in 2, that is 1, remainder 0. 2 in 1, okay, that is 0, remainder 1. So we pick up our answer like this, going from the lowest to the highest. So let's just rearrange it. That is 23 base 10 is equals to 10111 base 2. So let's go through our options together and see which of them is correct. This makes option B very correct. So remember that the Myschool team has provided you with certain tools to help you better prepare for your coming exams. So you can use the link in the description below to download the Myschool mobile app or get the Myschool software that you can install on your laptops and your computers. So join me as we tackle question number 54. A box contains 2 red balls and 4 blue balls. A ball is drawn at random from the box and then replaced before a second ball is drawn. Find the probability of drawing 2 red balls. So definitely this is a question on probability. Okay, so we are told that a box contains 2 red balls, okay, and 4 blue balls rather. So that means total number of balls available are 6. So we have 6 balls. So the probability of drawing 2 red balls first is 2/6. Okay, so the question says find the probability of drawing 2 red balls. So at first that is 2/6. We are now told that the second ball is also drawn and it was replaced before we draw out the second one. Let's take the question again. Say a ball is drawn at random from the box and then replaced before a second ball is drawn. Okay, so the first drawing brings out 2/6, okay, and there is a replacement. That still means means times, okay, it is being replaced. That is, the first red ball we picked is being dropped back. So that means 2/6, okay? So 2 here 1, 2 here 3, 2 here 1, 2 here 3. 1 times 1, that is 1. 3 times 3, that is 9. So probability of drawing 2 red balls is 1/9 in the context that they have been replaced before the second drawing. This is 1/9. So do not forget to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as we release the next videos. So question number 55. Looking at the diagram, which one of the following gives the members of the set A complement intersection B intersection C? So the first thing we did is to replicate this diagram we have on our screen right here on our whiteboard. Okay, so this is it. So the question is to find A intersection B intersection C. So we can still do something like this. So at first, let's find B intersection C. So what are the members of B intersection C? So this is B, okay, and this is C. So where is B intersection C? This is it, T and U. So we have U, T, okay? All right, so let's now find A complement. What is A complement? The things that are not in A but are present in universal set. So this is all of A. So we are not looking for things that are not in A. So the elements not in A. So we have S, we have W, okay? We have X, we have Y, we have Z. So we have S, okay? We have W, we have X, we have Y, we have Z, okay? So that is A complement. So the question is, A complement intersection or intersects B intersection C. So let's see, at what point did they use to intersect? Are there any common elements we can find? We have U here. Do we have U here? No. We have T here. Do we have T here? So therefore, we can say that A complement intersection B intersection C is an empty set or a null set, okay? Whichever way you want to put it, you can leave it blank like this or you can still put it in this, okay? So if we scan through our options together, option A is very correct. We have question 56. Calculate the area of an equilateral triangle of side 8 centimeters. So let's solve this together. An equilateral triangle means all sides and angles, they are all equal. Okay. Remember that this diagram is not an absolute scale. Okay, it doesn't have the correct measurements. We just pull this up. Okay, so all of the sides are equal. So they said one of the sides is 8 centimeters. So definitely this is 8 centimeter, this is 8 centimeter, and this is 8 centimeter. So definitely all of the angles too are equal. So this makes 60, 60, 60. Since sum of angles in a triangle is 360, 60, okay? So 60 plus 60 plus 60 gives you 180. So remember that the formula for the area of a triangle is half AB sine theta, okay? Or you can say, for an equilateral triangle, you can still say root 3 over 4 times a square. This still gives you the same thing. We can even prove it. Okay, let's have this. That is half times a. What is our a? Our a is 8. Our b2 is also 8, okay? Times sine 60, where sine 60 is 0.8660 or root 3 over 2. Half times sine 60, right? Times 8 times 8. It's still the same thing. We have half times root 3 over 2 times 8 times 8. So half times, okay, 1 times root 3, that is root 3, over 2 times 2, that is 4, okay? So that's root 4, root 3 over 4 times 8 times 8. So if you relate this that we got here to this, we can say it's the same thing, okay, for this particular question. Okay, so for an equilateral triangle, we have half times AB sine theta or root 3 over 4 times a square. You can say it's the same thing. So let's just work with this we've been trying to prove, okay? Times 8 times 8. 4 here 1, 4 here 2. So we'd have root 3 times 2 times 8, that is 16. That gives us 16 root 3, okay? So 16 root 3. If we go through our options together, option D is very correct. Question 57. Approximate 0.9875 to 1 decimal place, okay? So when we round up 5, this becomes 8. We round up 8, this becomes 9. We round up this 9, this gives you 1 to the other side, okay? So it becomes 1.0 to 1 decimal place. So the correct option here is option B, 1.0. Remember, the link in the description below has been provided just for you, so you can ask your questions right now and you'll be taken to the Myschool website where solution providers are waiting for you. So join me as we tackle question 58. Simplify 25 raised to power 2 times 8 raised to power minus 2 over 3. This is a very simple question to tackle, just as we say usually, and we do so. Okay, so this is the question we have here. So this 2 beneath means the root and this means the power. So that is 25, the square root of 2, okay, raised to power 1, all right, times this 8. This becomes the root, the third root, or the cube root of 8, raised to power 2, where the minus here means 1 over, okay? So square root of 25 is 5. I don't need to put this because this represents square root, but you can put it for clarity's sake. So square root of 25 is 5. 5 raised to power 1, that's the 5, times the third root of 8, or the cube root of 8 is 2. That is, what number will you multiply to itself 3 times that will give you 8? That is 2 times 2 times 2. That gives you 8. So the cube root of 8 is 2. 2 raised to power 2, that is 4. So we are going to have 1 over 4. So 5 times 1, that gives us 5 over 1 times 4, 4. So your answer is 5 over 4, or 1 whole number 1 over 4, or if you want to have it in decimal form, that can be 1 whole number, or sorry, 1.25. So whichever one works for us. So let's count through our options together. We are going to see that option A is very correct. So if you have gone through any of our videos and you'd like to share 1 or 2 recommendations or steps that are better off compared to what we have given so far, please use the comment section below, indicate the question number and the recommendations or solutions you would like to share. Number 59, from a point R, 300 meters north of P, and a man walks eastward to a place, Q, which is 600 meters from P, okay? Find the bearing of P from Q correct to the nearest degree, okay? So very well, we just have to represent this question in diagrammatic form, and that is what we have exactly on our board, okay? We said from a point P, R is 300, from a point R rather, it is 300 meters north of P. So this is the north of P, and that is 300 meters, okay? Then we now have that the man walks eastward to a place Q. So this is the east of P, okay, which is 600 meters from P. This is the east, this is the northeast, okay? This is the northern side of P. Okay, so we have to find the bearing of P from Q, okay, correct to the nearest degree. This is very easy to solve. So if you look at this diagram, we can use the Pythagoras theorem to solve this, or we can use the normal trigonometric ratios to find it, okay? So remember our SOHCAHTOA, right? So we have, this is the adjacent, we have the hypotenuse. So basically, to find the angle P here, we can just say, we can use cos theta, okay, equals adjacent over hypotenuse, okay, where the adjacent is 300 over hypotenuse 600. So we have 3 here 1, 3 here 2. So we have 1 over 2, which is 0.5. So cos theta equals 0.5. Therefore, theta will be, once you send in this cosine, it becomes inverse, okay? That is cos inverse of 0.5, and that is 60 degrees. So theta equals 60 degrees. So what we have here is no longer theta, it is 60 degrees. Okay, so let's just do this very simple. Remember that sum of angles in a triangle is 60, right? So 60 plus 90, this is angle 90, that gives you 150, okay? So 150 from 180, and that gives you 30. So this place is 30 degrees. So we are asked to find the bearing of bearing of P from Q. So from P from Q, okay? So this is 30. If you look at Q from Q, this is 90. Remember our 4 cardinal points. This is 90. This adds up to 180. This adds up to 270. And this makes 360 degrees. So let's look at this together. This is 90, okay? This is 180. So this side is supposed to be 270. But from the 270 already, we've taken out 30. So that will be 270 degrees minus 30 degrees. What we'll be left with is 240 degrees. So we can see from here, this is 240 degrees. So we can see from here that the bearing of P from Q is 240 degrees. That makes option D very correct. Question 60. Add 54 base 8 and 67 base 8, giving your answer in base 8. So we just have to first replicate this question on the board. So this is what we have, 67 added to 54, both in base 8, leaving our answer in base 8, okay? 7 plus 4, that is 11. So we can write 11 in base 8, so we just find this. 8 in 11, normal division that you do, that is, it can only go once, remaining 3. So we write the remainder first. So the remainder is 3. We carry 1, okay? So 1 plus 6, that is 7. 7 plus 5, that is 12. So 12 in base 8 is what? 8 in 12, it can only go once, remaining 4. So you write the remainder first, then you carry the 1 again. So 1 plus nothing, that gives you 1. So our answer is 143 base 8. So if we go through our options together, option D is correct. Question 61. If x y can take values from the set of these numbers 1, 2, 3, 4. Find the probability that the product of x and y is not greater than 6. That is, it can be 6, but it should not be more than 6. So this is what we have to do. These are the values 1, 2, 3, 4. So if x and y can be 1, 2, 3, 4, okay? So this is, let's say this represents the column for y, and this represents the column for x. So the question requires that if x and y can take values from the sets, so x has taken its values 1 to 4, y has taken its values 1 to 4. So we have to find the probability that the product of x and y will not be greater than 6. It can be 6, but it should not be more than 6. So let's look for how many numbers that when we multiply them together, they will give us 6 or something lesser, okay? So let's look at it. This is for x column, this is for y column, okay? So this is 1 times 1 gives you 1, 1 times 2, 2, 1 times 3, 3, 1 times 4, 4. So that is, when x is 1 and y is 4, it gives us 4, okay? The same thing goes here. 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, okay? Let's go to when x is 3 and y is 1. What do we have? 3 times 1, that is 3. When x is still 3 and y is 2, what would that give us? That is 6. When x is 3 and y is 3, what do we have? That is 9. When x is 3 and y is 4, that gives us 12. So now let's consider when x is 4 and y is 1, that gives us 4. Remember product. When x is 4 and y is 2, that gives us 8. When y is 3, that gives us 12. When y is 4, that gives us 16. So recall the question again. Find the probability that the product of x and y, the product of x, that is when x times y, is not greater, is not more than, it's not more than 6, okay? So let's take the ones that their product is not more than 6. We have this, 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 we have this. It's not more than 6. It can be 6 but not more than 6. So this is more than, so we will not touch it. We have this, we have this. This is 9, it's more than 6. This is more than 6. We have this. This is more than 6. This is more than 6. This is more than 6. So let's see which of the products of x and y, which of them are not more than 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 numbers. 10 products out of how many products altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Out of the total outcome, which is 16. Okay, so our answer is 10 over 16, or if you want to still simplify, 2 here 5, 2 here 8. Okay, so if we go through our options together, option A is very correct. So we have question 62. If n equals 3, 5, minus 4, 6, minus 3, minus 5, minus 2, 2, and 1, this is a matrix, okay? Find the determinant of n, that is this. So we just have to replicate this question on our board, okay? So to find determinant of matrix n, okay, we have to make sure that n is a square matrix. What do we mean by a square matrix? It is one that has equal number of columns and rows, okay? So we have how many columns here? We have 1, 2, 3. How many rows? 1, 2, 3. Okay, so this is definitely a square matrix. So how do we go about finding its determinant? It's very simple. You pick the numbers in the first row, which are these. Okay, so while we are working on the first number, okay, every other numbers in that column, those numbers have a kind of covering or protection, so they are not involved. So this is what we are going to do. So for the first column, we would have 3, into brackets. So you can see we have here, aside from its column, so we have minus 3 times 1. So let me make this, okay, a bigger bracket. Okay, so we have minus 3 times 1. Okay, can you see that? Then this 2 multiplies itself, minus into brackets minus 5 times 2. Do we see it? Okay, so for the next column, which is minus then 5, we open the big bracket. Okay, so when we are working on 5, the numbers as that share the same column with 5, they are under a kind of protection. So we are going to have 6 times 1 minus, so we have minus 5 times minus 2 okay. Then for the last column, we have plus times minus 4, so that still gives us minus 4. Okay, or we can, for clarity's sake, let's just have plus into brackets minus 4, then this big bracket. Okay, so we are working on 4, so every other numbers in this column, they have a level of humility or protection. Okay, so we are looking at this as 6 times 2 minus 2 times minus 3. Okay, so now let's produce this answer. So here we have minus 5 times 2, that is minus 10. So minus times minus, that gives you plus. So here we would have, okay, so let's bring this here. Just follow me as we walk. So this will be 3 big brackets, minus 5 times 2, that is minus 10. Minus times minus, that is plus. Okay. Minus 3 times 1, that is minus 3. Isn't it? So we have this, minus 5. Okay. 6 times 1, that is 6. Minus 5 times minus 2, that gives you plus 10. Minus times minus is plus. 5 times 2, that is 10. So this is plus 10. Plus times minus, that is minus 10. Okay, then we have here plus times minus, this is minus already, minus 4. We open the big bracket. 6 times 2, that gives you 12. Okay. Minus times minus, that is plus. 2 times 3, that is 6. So we have plus 6. Plus times minus, that is minus. Okay, very well. So minus 3 plus 10, that is plus 7. Okay, so 6 minus 10, that is minus 4. Minus 4 times minus 5, that gives you plus 20. Okay, let's not rush it into brackets, minus 4. Okay, then we still have minus 4 into bracket. 12 minus 6, that still gives you 6. Okay, so let's point out our answer to this part. All right, so 3 times 7, that is 21. Minus times minus, that is plus. So 5 times 4, 20, that is plus 20. Okay, minus 4 times 6, that is minus 24. Okay, so you can make this more easier. Plus 20 minus 24, that gives you minus 4. Okay, so minus 4 plus 21, that is 17. Or you can take it the other way around. 21 plus 20, that is 41. 41 minus 24, that is 17. So determinant of n is 17. So if we scan through our option C is very correct. So that is it for this segment, but there's definitely more to come. I know you are enjoying this content and you would like us to bring you more of it. So please hit the like button, click on the subscribe button, and tap on bell notifications so you can get informed as we update our videos.